Hey gang, today we're going to be using the quadratic formula to solve the roots of a quadratic equation. We've done this already by completing the square and factoring, but you're going to see that using the quadratic formula is going to help for when we have an equation that cannot be factored. And sometimes we're going to have roots that are fractions or irrational numbers, and that is when this is necessary. All right, so let's take a look at that formula. Given any quadratic equation of the form y equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0, we can find the roots of the equation by the quadratic formula. And that's this fancy equation here. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is a really tricky equation. It helps if you memorize it because you will recall to use it really quickly instead of factoring or completing the square when you need it, but it is also always in the reference page on the Regents exam. So let's take a look at what we got here. Here's our first problem. Now we need to start again by recognizing that this is A, this is B, and this is C. The B in this case would be 1, and this is already in standard form, so we don't have to rewrite it. We can just start plugging it into the equation. So we have x equals negative b, which in this case is negative 1, plus or minus the square root of 1 squared is 1 minus 4 times a, which is 2, times c, which is negative 6, all over 2 times 2, which is 4. So x equals negative 1 plus or minus the square root of 1, and then a negative times a negative is a positive. 4 times 2 times 6 is 8 times 6, which is 48, all over 4. Now we can simplify that further. We have x equals negative 1 plus or minus the square root of 49 all over 4. That makes this one really easy to do because 49 is a perfect square. So we get x equals negative 1 plus or minus 7 all over 4. And just like when we have factors, when we're factoring, we have two binomials that we set equal to 0. Here we have two roots that we can still solve for, negative 1 plus 7 over 4 or negative 1 minus 7 over 4, making this 6 over 4, which is 1.5, or negative 8 over 4, which is negative 2. So these are rational roots because I can write them as ratios. And I want to prove to you that if I were to put that equation in my calculator, that 2x squared plus x minus 6, and pull up the graph, sure enough, my roots are 1.5 and negative 2. And if I look at the table, negative 2 matches up with 0. And if I change my table setting to 0.5, 1.5 also matches up with 0. So I've proven that I've gotten the correct answer and found the correct x values, or where this equation is equivalent to y being 0. All right, let's take a look at the next example. In number 2, this 0 should be up here. I'm not sure why it's there. We have a is equal to 1, b is equal to 2, and c is equal to negative 1. So we have x equals negative b, which is negative 2, plus or minus the square root of, that 2 squared is 4, minus 4 times 1 times negative 1. 1 being a, negative 1 being c, all over 2a, which is just going to be 2 in this case because 2 times 1 is 2. So x equals negative 2 plus or minus the square root of 4, and then minus and minus make a plus 4 all over 2. So x equals negative 2 plus or minus the square root of 8 all over 2. Now, 8 is not a perfect square, so that makes this one a little bit more challenging. I'm not going to be able to just take the square root. So I have x equals negative 2 plus or minus the square root of 8. We know 8 is 4 and 2. Square root of 4 is 2. Leave the 2 all over 2. Lots of 2's going on there. And then we can simplify this because 2 and 2 are divisible by 2. We leave the radical alone. We get x equals negative 1 plus or minus the square root of 2, which means we have irrational roots. And we can leave our answer that way. You could also split it up, so we would have negative 1 plus radical 2, and we'd have negative 1 minus radical 2 as our two answers. So the roots are going to be really close to that negative 1. If we wanted to try to check, we could see that we have x squared again plus 2x minus 1, and we could pull up the graph. And here we have that negative 1 plus radical 2. Oh, I'm sorry. Negative 1 plus radical 2 would be about 1 something. So that would be here, right? And then negative 1 minus radical 2 is going to be about negative 3, a little bit more, or a little bit more than, or right around that 3 area, a little bit before the 3, which is right here. I know that's a little confusing, but radical 2 is like 1.7 something. So you could kind of try to match it up there. It's a little tricky to see because it's irrational, right? But again, whenever it's an irrational root, it's because you cannot simplify the radical all the way through. All right, let's take a look at another example. Number 3. Here we have x squared minus 7x plus 6. So this is our a, this is our b, this is our c. So x equals negative b. So that's negative 7, which makes it positive 7, plus or minus the square root of. Now, negative 7 times negative 7, guys, is positive 49. Don't be fooled by that. If you put negative 7 squared in your calculator, sometimes it comes up as negative 49. But that's because your calculator is reading it as negative 1 times 7 squared. All right, so a negative times a negative is a positive. You guys know that. Don't use your calculator, use your brain. 49 minus 4 times 1 times 6 all over 2 times 1, which is 2. So x equals 7 plus or minus the square root of 49 minus 24 over 2. So x equals 7 plus or minus the square root of 25 over 2. Another easy one because 25 is a perfect square. We get x equals 7 plus or minus, no square root anymore, 5 over 2. So we could have 7 plus 5 over 2, or we could have 7 minus 5 over 2, which makes this 12 divided by 2 or 2 divided by 2. So that's 6 and 1, which are rational roots because they're whole numbers. Okay, so again, we could check. If we plug that into our calculator, we've got x squared minus 7x plus 6. Pull up the graph, and sure enough, our roots are at positive 1 and positive 6. And if we pull up our table, we can see at positive 1 we match up to 0, and at positive 6 we also match up to 0, proving that we've got the right answers. All right, let's continue. Number 4. All right, so for number 4 we have x squared plus 2x minus 4. So our a is again 1, our b is 2, and our c is negative 4. So we have x equals negative b, which makes it negative 2, plus or minus the square root of 2 squared is 4 minus 4 times 1 times negative 4, all over 2 times a, which is just 2. So that's x equals negative 2 plus or minus the square root of 4 plus 16 all over 2. So x equals negative 2 plus or minus the square root of 20 all over 2. Now again, in this case, we know 20 is not a perfect square, but it has a perfect square factor of 4. So we have x equals negative 2 plus or minus the square root of 4 is 2, leave the 5, all over 2. And again, we can simplify. 2 is divisible by 2, so you're going to simplify that part when you can. 2 divided by 2 is 1, so that's negative 1, plus or minus 2 divided by 2 again is 1, leave the square root of 5. All right, so that makes that a little tricky. We can even take that a step further. This is again irrational. And we could round to the nearest tenth. So this could be x, or this could be negative 1 plus square root 5, or negative 1 minus square root 5. And there will be times where you're asked to estimate it, so it's good practice to try it. If we try the square root of 5, or we do negative 1 rather, plus second square root 5, we get about 1.2. And if we do negative 1 minus the square root of 5, we get negative 3.2. So we could check to see if we're close with our graph. So if we change this to x squared plus 2x minus 4 and pull up the graph, we do see about a little bit over 1 here. and a little bit more than 3 here. So verifying that we most likely have the correct roots. And again, they're irrational because we cannot simplify the square root of 20 to a perfect square. All right, so this is some tricky stuff. You're really going to take your time when you're plugging it in and watch your signs. You guys are going to complete the rest on your own and be sure that the equation is written in standard form first. So the last two are not written in standard form. Make sure you rewrite them in standard form before you start to plug them into the quadratic equation. I'll be around to help you guys out, of course.